Hi, welcome back to ChemTube channel. I'm Jaegu Wong. Today we are going to discuss the Terengganu trial, paper 3, 2020. Let's start. Let's look into question 1. Question 1 consists of 11 scientific skills. So each scientific skills 3 marks, so total is 33 marks. The experiments are conducted to determine the effect of position of metals in the electrochemical series on the heat of displacement. So diagram 1.1 shows the apparatus for experiment 1. 5 grams of iron powder is added to 50 cubic centimeter of 0.5 mole per cubic decimeter copper 2 sulfate solution, and the thermometer is used to stir the mixture. Okay, so we have all information given here. Iron powder is 5 grams. Then copper 2 sulfate solution is 50 cubic centimeter. So this is the volume. So it's a V. And 0.5 mole per cubic decimeter. This is the concentration. Is the M. Okay, let's look into the diagrams here. So the one spatula of 5 grams of iron powder is put into the copper 2 sulfate solution, which is blue color. Then after 5 minutes, okay, so this one is excess iron powder because it's not reacted completely. Then the copper 2 sulfate solution, it forms a colorless solution. Then the brown solid is formed. Okay, so the experiment is repeated by replacing iron powder with the zinc powder and the magnesium powder as shown in the table 1.1. Meaning that this experiment is repeated using iron powder and the zinc powder. Okay, so before we go to the questions, so I will show you one video on the heat of displacement.
"50 cubic centimeters of 0.25 mole per cubic decimeter copper 2 sulfate solution is poured into a polystyrene cup. The initial temperature of the solution is measured with a thermometer. Record the reading in the table provided. Excess zinc powder is poured into the copper 2 sulfate solution. Stir the mixture and record the highest temperature of the mixture in the table provided.
Okay, so in the video is using the zinc powder put into the copper 2 sulfate solution. So, okay, so you are given the reaction for 3 experiments. Or experiment 1, iron powder with the copper 2 sulfate solution. Set 2, zinc with the copper 2 sulfate solution. Set 3 is magnesium powder with the copper 2 sulfate solution. So here actually we can refer to the electrochemical series. So copper 2 sulfate solution refer to the copper ions. Okay, so first set is iron. So iron is here. So first set iron with copper 2 sulfate solution. Set 2 is a zinc. So zinc is here with the copper 2 sulfate solution. So set 3 will be magnesium. So magnesium is here. So magnesium with copper 2 sulfate solution. So meaning that the manipulative variable, we manipulate these 3 metals. Then the fixed variable will be the copper 2 sulfate solution. Okay. So first question, record the thermometer readings in the space provided in the diagrams 1.2 and 1.3 and 1.4 to 1 decimal place. Okay, so it's stated here is 1 decimal place. So it's 3 marks. So this is under scientific skills, measuring using numbers. So if we look into the diagrams here, okay, so the first reading is this one is 57, so 58, so each one, so this one should be 29, okay, so 29, then here 30. So the question mentioned round to 1 decimal place, so this one is 29, so it's 29.9, okay, 29.9, this is 57.9. Then remember to put in the unit for it, degrees Celsius. Okay, so this is for experiment 1. So experiment 2, okay, initial temperature are the same, so this is 29.9, this one is 59.5 degrees Celsius for set 2, zinc with copper 2 sulfate solution. Set 3, 29.9, then highest reading of thermometer will be 64.7 degrees Celsius. So all the numbers are recorded correctly, so you get score 3. Okay, next question. Okay, for the experiments that the manipulated variable, so is a MV. Just now I had mentioned to you. So is you can list out the metals: magnesium, zinc, or iron. Okay, there are 3 manipulated variables. Then you also can mention the metals above copper in the electrochemical series, also accepted. Then the responding variable, okay, already mentioned in the question, so it's the heat of displacement. Next, the constant variable is a copper 2 sulfate solution. No? Okay, so these are the variables, controlling variables. Next question. State one hypothesis for the experiment. So here, for the tips for writing the hypothesis, most of the condition we can use this formula. The direction MV, the direction RV. Direction must be stated correctly, such as increase, decrease, higher, lower, and so on. So we can put in the MV and RV here. So the further the distance between the metals from the copper in the electrochemical series, the higher the heat of displacement. So here we can determine distance between the metals from copper in the ECS is the MV. Heat of displacement is RV. So the sequence is correct. Then direction, this is the further is the direction, higher is the direction. So you get score 3. Okay. So if score 2 is reverse MV and RV, meaning that if you reverse the MV and RV, you goes to score 2. For example, for score 2, the heat of displacement increase when the further the distance between the metals from the copper in the electrochemical series. So it's reverse, so it's score 2. Okay, another example for score 2, the higher the position of metals in the electrochemical series, not mentioned from the copper. So the higher the heat of displacement, so it's not complete here. So it's score 2. Then score 1, the different metals affect the heat of displacement. So different or affect is referred to no direction. So if no direction, normally you can only get 1 mark for hypothesis. Next question is about observation and inference. These two must be continuous. Okay, so there are some observation you can write to get score 3. Okay, number 1, you can mention the temperature increase. This one is the easiest. Number 2, you can mention is brown solid is formed, or iron powder dissolve, or blue solution turns colorless. All these observation you all can get score 3, any one of these observation. And for score 2, the container becomes hot, or colorless solution form. These are the score 2. Score 1, solution change color or precipitate form. All these can get only score 1. Okay. For inference is explain the observation. Okay. So let's look into this example. The first observation, temperature increase. Why the temperature increase? Because it is exothermic reaction. Exothermic reaction. Under observation like brown solid form, iron powder dissolve, blue solution turns to colorless. You can write the inference. Copper is formed, for brown solid is formed. Then iron displaces the copper from its salt solution for the this of the observation, and the blue solution turns to colorless. Okay. So the inference must be tally with the observation. If you write temperature increase, your inference is exothermic reaction. Okay, for score 2, heat is release. No, not mentioned to surrounding. And heat change for score 1. Okay. This is for observation and inference. Okay, next, state the relationship between the position of metals in the electrochemical series with the temperature rise. Okay, so here you have to mention what is the relationship. Okay, this is under using space-time relationship. Okay, for me this is not really fulfill this scientific skill because no mention the time, but it's okay. So your answer should consist of position of metals in the electrochemical series and then the temperature rise. Okay, so the tips here, your answers should sound like this: the direction, position of metals in the electrochemical series, then the direction, the temperature rise. So the information here, do not change any wording from the questions. You just follow directly. Okay, so direction here you can mention increase, decrease, and so on. Okay, so suggested answer: the further the distance between the metals in the electrochemical series, the higher the temperature rise. Okay, so this is for score 3. For score 2, the higher the position of the metals in the electrochemical series, or you mentioned the higher the temperature rise. Either one correct, you get 2 marks. For score 1, you just mention temperature change. Okay, so for these questions, remember, you don't change any wordings in the questions. You just follow directly. Okay, next, interpreting data. So calculate the heat of displacement in the experiment 1. So I put the experiment 1 here is iron with copper 2 sulfate solution. Okay, so the temperature change is 29.9 to 57.9 degrees Celsius. So first step, we can find the calculate the Q. Q equals to mc theta. So m is the constant volume of the copper 2 sulfate solution. It's 50. C is 4.2. Okay, is the specific heat capacity. Then the theta is the temperature change. So highest minus the lowest. So you use your calculator, you get 55,880 joule equals to 5.88 kilojoule. Divide by 1,000 for joule, change to kilojoule. So after you get the Q, then you can count the number of mole. For the number of mole, we use the mv over 1,000. So m is 0.5, v is 50. Over 1,000, you get 0.025 mole. So once you get the Q, you get the number of mole, you can put in the delta H equals to the Q divided by the mole, you get 235.2 kilojoule per mole. So here we put in a negative sign to show the heat is released, because because it is exothermic reaction. Okay, so this is under interpreting data. So under predicting, so predict the heat of displacement when the aluminum react with copper 2 sulfate solution. Okay, so here given to you zinc with copper 2 sulfate is 210, magnesium is 336, and then iron is 121. So here we use the electrochemical series here. So compare with copper. So here, first set zinc with copper is 210. Okay. Then magnesium with copper 2 sulfate solution is 336. So if iron is here. So is 121. Okay, so let's see where is the location of aluminium. So aluminium is here. Okay, so aluminium is here. So meaning that the value of the heat of displacement must be lower than magnesium, but higher than zinc. So meaning that is between the value of 210 and 336. Oh? So any values between 210 and 336. Okay. So you can put in a value between the, let's say you put negative 250 kilojoule per mole. Okay. Okay, next, write the ionic equation for the experiment 3. So for experiment 3 is a reaction between the magnesium with the copper 2 sulfate solution. So it forms a magnesium sulfate and then the copper metal. So this is the ionic equations. Okay, so next, define operationally. So define operationally, you have to mention what do you do and what do you observe. So here, suggested answer. Okay, the temperature increase when 1 mole of copper is being displaced by a more electropositive metal from its salt solution. So temperature increase is what you can observe. So copper is being displaced by a more electropositive metal. So what should be done? Okay, so this is for score 3. Okay, this is for score 2, not score 3, sorry. So score 2, temperature increase. If you mention temperature increase, you get score 2. Or you mention copper is being displaced by a more electropositive metals from its salt solution. So you can get score 2 if you write this one or this one. Okay, so if you write temperature change, you get 1 mark. Okay, score 1. Okay, so classify the following metals into metals that can displace the lead from the lead 2 sulfate solution. Okay, so this one we have to look into the electrochemical series. The one higher than lead in the electrochemical series, it can displace it. Then lower than it, you cannot displace. So silver is lower, zinc is higher. So this one, copper is lower, aluminium is higher. So meaning that metals that can displace the lead is the zinc and aluminium. That cannot will be silver and the copper. Okay. Then score 2, if you give any 3, you arrange any 3 metals here correctly. Okay. Score 1 is any one correct or totally reverse. Totally reverse means you reverse these metals and these metals, you totally reverse, you still can get score 1. Okay. Now we look into the question 2, is a planning of experiment, so total is 17 marks. Diagram 2.1 shows the conversion between the teacher and the students. Okay. So the teacher tells the student, today I would like to conduct an experiment for the chemical reaction for the alkali metals of group 1 with water. Can you give me what we will get for the observation after the experiment is done? Okay, so this student mentioned sodium move fast in water, lithium moves slowly in the water, then potassium move very fast in the water, teacher. Water pH change after the reaction. Well done to all of you. Okay, so the question here, based on the diagrams, by naming the group 1 metals, plan a laboratory experiment to study the reaction of group 1 metals towards water. Your planning should include the following aspects: problem statement, variables, statement of hypothesis, material apparatus, and then procedure, then finally tabulation of data. Okay, before we go into the discussion, so let's look into this video. So first cut the metals and then put it into the basin of water, and then we see the observation. Okay, this is repeat with another metals. Then for potassium, you can see the movement. Okay, so from here we can see the reactivity of the group 1 metals with the water. Okay. So first problem statement. To get score 3, you can mention, does the lithium, sodium and potassium shows the different reactivity when react with water? So ask a question. It's a problem statement. Or another suggestion here, how does the chemical property of lithium, sodium and potassium when react with water? So these are the score 3. Score 2, how does the chemical property of metals differ? Not mention what type of metals here, so you have to mention, and then not mention when react with water. Score 2 and then score 1. To study the chemical properties of metal in group 1. Normally if the student write the DM will get score 1 only. Okay, next, variables. So manipulated variables here, type of metals, or you list out all the metals here, lithium, sodium and potassium. Responding variable, reactivity of alkali metals with water. Then fixed variable is the water or size of the alkali metals. Okay, then hypothesis again, direction MV, direction RV. Okay, so score 3, when going down the group 1, the alkali metals becomes more reactive when react with water. Another one, the lower the position of the metals in group 1, the higher the reactivity towards water. Okay, this is for score 3. Score 2, the higher the reactivity towards water, the lower the position of the metals in the group 1. So this one is reverse MV and RV, because our reactivity is RV, then group 1 metals is MV, so it's reverse. So you get score 2 only. Then the more reactive the reaction, the lower the position of the metals in the group 1. Okay, so this one also reverse MV and RV. Score 1, metals in group 1 can react with water. No direction, without direction. Position of alkali metals affect the reactivity. So affect also no direction. Okay, so this one is no direction. Okay, or the reactivity of the group 1 is different towards water, so no direction. So remember, in the hypothesis, you must put in the direction. It's very important. Materials and apparatus. Score 3. Materials, sodium, potassium, ammonium, lithium, sodium, potassium, litmus paper, and then the water. Apparatus here, basin, forceps, and knife. So we have 1, 2, 3, 4, 5 materials and 3 3 apparatus. Okay, so notes here, maximum we can get 1 materials and 1 apparatus from your diagrams or procedure, or maximum one only. Okay, for score 2, able to list 2 materials and 2 apparatus correctly, and then also same maximum we can take or find 1 materials and 1 apparatus from the diagram or procedure. Then score 1, able to list 1 materials and 1 apparatus. Okay, for score 1. For procedure, okay, step 1, cut the lithium using the knife and the forceps. Step 2, you clean the lithium using the filter papers. Then drop the lithiums into the basin, half filled with water. Then the observation is recorded. Then finally, after that, put the litmus paper into the water, and then the experiment is repeated with sodium and potassium. So sodium and potassium here you must mention, okay, what metals. Don't write with other metals. Okay, so cannot. You must list out all the other manipulative variable. Okay. So for score 2, you can list out step 1, 2, 4, 5, and 6. Meaning that step 3 not mentioned, you can get score 2. Then score 1, you mention 1, 2, and 4. If you mention these 3 steps, you can get score 1. Okay. And last question, tabulation of data. So you have to put the tabulation of data, put the data in the table. So you draw a table. So type of metal actually is MV. This is the clue. MV, then observation, or you can write the responding variable. Okay. Then you list out all the metals, lithium, sodium, and potassium. Okay, so this is score 2. Then score 1, you mention type of metal and then observation without mentioning the type of metals involved. Okay, so here you can only get score 1. Then for the paper 3, planning of experiment, the observation you can leave it blank. Leave it blank because you are planning the experiment. Okay. So that's all for today. Okay, thanks for watching.